All right, let's just jump right in. We're going to talk about something, well, something pretty wild. It's one of the most radical ideas out there in physics right now. Imagine building our entire reality. I'm talking space, time, matter, gravity, the whole shebang, from just one single logical rule. That's the promise of what's called omega theory.
So, you gotta ask the big question, right? Where do the laws of physics even come from? I mean, we've got these amazing equations, they describe the universe with incredible accuracy, but why those rules? Where did they originate?
Usually in physics, we kind of just accept them, right? We treat things like gravity or quantum mechanics as givens. They're the foundational rules of the game. We don't really explain why they exist. We just say, okay, these are the rules, and go from there. We find them, we don't build them.
But this is where omega theory just completely flips the script. It's not satisfied with starting with a bunch of rules. No way. It wants to start with nothing, an empty stage, and from a single logical spark, it tries to build not just the characters, but the stage itself. So how in the world do you get a universe from nothing? The trick here is that the theory starts with something that's even less than empty space. It begins with just pure potential. Nothing's defined yet. This starting point, they call it the plane. And you gotta get your head around this. It's not a vacuum. It's not empty space. It has no dimensions, no distance, no time. It's just a set of potential spots, and every single one is identical to all the others. A perfect, total symmetry. Nothing is different from anything else, so no information can even exist. So if you want a universe, you have to break that perfect symmetry. And omega theory suggests something called a genesis operator. It's not a physical thing, it's a purely logical action. Just imagine this silent, symmetric grid, and this operator just goes, that one right there is different. And boom, that's it. With that one logical move, you have the first difference, the very first bit of information, the seed for everything else. All right, section 2, the engine of change. So we've got one little point that's different. Great. But a single dot just sitting there isn't a universe, right? It needs to move, to evolve, to do something. So what's the engine? What kicks it all off?
Yeah, that's the big question. A static point is boring. A universe has to process. So what pushes that first domino? Why wouldn't this one different point just stay a different point forever? Well, the theory says that the act of making that distinction in the first place creates a kind of tension, an instability. And this is where it gets really clever. The theory says the precision of the first difference forces the system into motion. This is the engine of time. Think about it. By making the state of that point perfectly known, it is different. You create an uncertainty in how it's changing. The system is basically forced to move. It can't stay still. And that tension, that's the engine of the universe. That's what starts the clock ticking. And this whole engine is described by a single, beautiful master equation. Just one rule. And inside this one rule, you've got the seeds of everything. You have the influence kernel. That's what decides how much neighbors affect each other. That becomes space. Then there's information feedback. This is the idea that information that's already there doesn't like to change. That's inertia. And finally, the clock drive. This part gives every point a little internal tick-tock, an internal rhythm. And that becomes time. Okay, section 3, building space and time. So we've got the rule. Let's see what happens when you just let it run. When you apply this one single rule over and over again, something amazing starts to happen. You can literally watch the fabric of reality build itself. So at time equals 1, you get flow. That first distinction, it's not a point anymore. It spreads out to its neighbors, kind of like a ripple in a pond. Then at time equals 2, you get repeat. That ripple, it settles down into a steady, synchronized, oscillating rhythm. It's like the universe's first clock starts ticking. And finally, at time equals 3, you get stable. That rhythm can actually fold back on itself, creating this locked, self-sustaining pattern. And that's the birth of the very first particle.
And this is a total game changer for how we think about spacetime. The standard view is that spacetime is this pre-existing box, right? A container that just holds everything. But in omega theory, no. It's an emergent property. Space is just the network of connections between all these points. And time, that's just counting the repeating cycles on that network. Spacetime isn't the container, it's a result of the interactions. All right, section 4, when logic becomes matter. Now this is where things get
really, really deep. We're going to talk about the connection between pure information and what we call physical mass. This quote says it all. Mass is the latency of the universe. Just let that sink in. Mass isn't some fundamental stuff. It's literally a processing delay. It's lag in the cosmic computer.
Okay, so think of a particle as a really dense, complex chunk of information, like a big, complicated file on a computer. For the universe to move that particle, it has to update all the information in that file. And the bigger and more complex the file, the more processing power it takes to update it. That resistance, that computational cost, that's what we feel as mass. And this isn't just some cool-sounding analogy. The theory actually derives a formula for this, right from its basic rules. It says that mass is equal to the information processing cost divided by the speed limit of the network squared. And that speed limit, by the way, is what we call the speed of light.
And what happens when you just rearrange that formula a little bit? You get E equals mc squared, the most famous equation in physics. But what's so incredible is that here, it's not just an assumption. It falls right out of the logic. It's a direct result of mass being nothing more than the cost of processing information.
So, Section 5, gravity, the cost of information. Okay, if mass is just the cost of information, then what on earth is gravity? Let's break down how this theory explains it. Step 1. Let's start with empty space. Picture it as a perfectly flat, uniform network. Information can flow anywhere it wants, easily and evenly. Everything is in balance.
Step 2. Now, let's drop in a massive object. Remember, that's just a really dense cluster of information. This thing creates a processing bottleneck. It's like a server that's suddenly trying to do a ton of calculations. It slows down the network all around it.
Step 3. The rest of the network has to deal with the slowdown. So influence information starts to flow towards the bottleneck to help with the heavy computational load. The network itself has to bend and deform to handle this information traffic jam. And that bending, that warping of the network, that is what we experience as gravity. I mean, that is just an incredibly elegant way to think about the universe. But, a cool idea is one thing. A scientific theory has to be testable. So is there a smoking gun? Is there something we can actually look for that would prove this is right or prove it's wrong?
It turns out there is. OMA theory makes a very specific, testable prediction. It says that when two black holes smash into each other, the insane amount of information processing going on isn't perfectly clean. It should create these tiny little hiccups in the gravitational waves that come out. They call them information modulation sidebands, basically specific extra frequencies in the signal. If our observatories, like LIGO, could actually detect those exact frequencies, that would be huge. It would be powerful evidence that, yeah, the universe really is a kind of computational system.
And that leaves us with the final big question. Is our universe the ultimate computation? Because if a theory like this is on the right track, it means reality isn't just described by math. It is math. It's a process. Every star, every planet, you, me, we'd all just be a part of this single incredible computation unfolding moment by moment from one single rule.